Okay. All right. When you need to calculate the circumference, when would you need to calculate the circumference of a circle? Jahan?
Perimeter of circle.
When we want to know the perimeter of the circle, okay? When we want to know the distance around the circle. So if we were thinking a circular garden and we wanted a fence, that would be circumference, right? What other example can you think of when you would find circumference?
What about the Ferris wheel one?
The Ferris wheel one rotation. How about the bike one?
Oh
The unicycle one, okay. When would we need to calculate the area of a circle? Alan?
When you're trying to like fill something in, I guess.
Filling in would be volume.
Yeah.
Covering is area, okay? So give me an example. What kind of examples do we have today?
we had the cookie one with the spread.
The cookie and the frosting, okay, that was area. Go ahead, Alan. The tablecloth, okay, that's area. All right, if we're painting, that's area. Okay? All right. What do you need to know to estimate or calculate the circumference of a circle? Kimberly?
Diameter.
You need to know the diameter. What if I give you the radius?
Just multiply by two.
I just have to double it to get the diameter, right? Okay. What do you need to know to estimate or calculate the area of a circle?
The radius.
The radius, okay? If I give you the diameter, can you find the radius?
Yes.
Okay, somebody had a question yesterday. Because yesterday in the practice problems, I gave you the circumference and you had to find the area. Somebody wanted to know, if I give you the area, can you find the circumference? If I give you the area, can we find the circumference? I thought that was a great question. I don't remember who asked it. So if I give you the area, so let's say the area is 176.6 feet squared, and I want to know what is the circumference. So what do you think we're going to do, Jahan?
What's about 53.4?
All right, so let's think about it. If we're down, let's go back to that cheat table we had. Radius, diameter, circumference, area's down here, and that is pi r squared. So what are you going to do?
I remember with the chart thing, you would do all I get down to radius, but I don't remember what to. There was something pointing down to area.
Okay, this went down here, and you did times pi r squared.
Oh, yeah.
Okay, we've never done this before, but let's go ahead and try it. If I give you the area is 176.6 equals pi, let's call pi 3.14. We don't know the radius squared. So what are you going to do to get radius squared by itself? What's attached to it?
3.14.
How is it attached?
Multiplication.
So we're going to divide both sides by 3.14. I'm going to teach you something new today. So we get r squared equals let's see, 176.6 divided by 3.14. Oh, it's 56.24, and it keeps going. We're just going to call it approximately that. Now, that's saying something times something is 56.24. Does anybody know how to undo squaring?
Divided by the same number.
Nope. Okay, if I said 81, what times what equals 81?
9 times 9.
9 times 9. If I say 64, what times what equals 64?
8.
8. So we're undoing squaring. To undo squaring, you take the square root.
Oh yeah.
So look at your calculators. You should have where it said x squared. It may be the second key, or you may have the square root symbol. Do you have the square root symbol? Okay, so you're gonna hit second. Oh, let me see. You're gonna hit second and then x squared. Okay, on the calculators here at school, you're gonna hit second x squared, and that should give you the, it's called a radical, the square root symbol, and then put 56.24 in there. What do you get?
56.
Do you get 7.4993333? Okay, we're gonna call that 7.5. So that means the radius is 7.5. Okay, if I know the radius is 7.5, can I now find the circumference?
Yes.
Okay, so I would multiply 7.5 times, so I know this is 7.5. What do I do to get the diameter?
Times 2.
Times 2, that's going to be 15. And what do I do to get the circumference?
Times pi.
Times 5. Okay? So can we go the other way? We sure can. That was a great question. All right, back to this. All right, problem number 1. In each problem, decide whether the circumference of the circle or the area of the circle is most useful for finding a solution. Explain your reasoning. A car's wheel spins at 1,000 revolutions per minute. The diameter of the wheels is 23 inches. You want to know how fast the car is traveling. What should you find?
The circumference.
The circumference. Why?
Because the question is about how much rotation.
Rotations. Good. Okay. A circular kitchen table has a diameter of 60 inches. You want to know how much fabric is needed to cover the table.
Oh.
Michael? Area. Why? Okay, you're covering the whole table, okay? A circular puzzle is 20 inches in diameter. All of the pieces are about the same size. You want to know how many pieces are in the puzzle. Kimberly,
It's an area.
do we agree with her? Area?
Yes.
Why? Why area?
Because it said how many pieces are in the puzzle, so we're covering.
Inside the puzzle. You want to know about how long it takes to walk around a circular pool.
Circumference.
Circumference, that one's
Says
easy.
around.
Because you're going around. Good, very good. Anybody need more time? Okay, I'll wait. We good? You good, Alan? Okay. Question 2. The city of Paris, France is completely contained by a circular road. Yes, I'm getting out my answer key. So I make sure I do it right. Okay, that's what I thought. All right, they want us to estimate the circumference of Paris. So if you look at this map, see this road right here? It's pretty much
A lumpy circle.
a circle, and here's Paris, and Paris is pretty close to the center. All right, so they want us to estimate the circumference of Paris. All right, so what do I need? What measurement do I need to find circumference? Circumference equals
Diameter.
pi times the diameter. Cherry pie's delicious. Okay, so it looks like I need to know the diameter. So what I did,
Maybe we could try to find.
I took, and I really did this at home, I took a sticky note. And I marked what that was.
Whoa.
That's 1 mile, okay? Then I went up here and said, okay, that's about the center, so that's 1 mile. That takes me to that road. That's 2 miles, takes me to that road. That's 3 miles. So it looked like approximately from here to here was 3 miles. Okay, what is that? Is that the radius or the diameter?
Radius.
It's the radius. You told me I needed the, so what's the diameter?
6.
6 miles, so we're gonna take 3.14 times 6. What do you get?
18.84.
18.84. Now because it says about, and you know that we did a lot of estimating here, right? Could we call it about 20 miles? Because generally when you estimate stuff, you do it to the nearest 10 miles or so. So could we say about 20 miles?
Yes.
Yes.
For the area.
No, for the circumference.
Okay.
Okay, now we want to know the area. Okay, we're going to use that same 3 miles, but now what is the formula for area of a circle?
Area equals pi r squared.
Good, apple pies are too. Okay, we're going to use that same 3.14. I mean, we're estimating all over the place here, right? Because pi is not 3.14, so that's an estimate. That was a real estimate. So we're going to take 3 squared. So what do you get there?
28.26. Oh no.
3.14 times, what's 3 squared? 9. So that would be,
28.26.
and if we're following the same rules, where we're going to go to the nearest tens,
It would be about 30.
about 30 miles is the area, miles squared. And this is 20 miles. Okay, how do you feel about that? Okay, didn't have a ruler to do it, so I just took my sticky note and made a little ruler, okay? And that's something you may have to do on a standardized test if they give you a map. They may not give you a ruler, so you can make your own little ruler, all right? Questions you have for me? Alan?
I don't know if it's just that I didn't do this really quick.
Is it making sense?
Mhm.
Okay. Can I erase?
Um,
Why don't you take a screenshot of it? Are you good? There you go. Okay. Alright, here's a diagram of a softball field. About how long is the fence around the field? Fence around the field. So we want this, this, and this. Correct? Okay, what shape is this? Well, we can easily get this and this.
I know it's a quarter of a circle.
That's a quarter of a circle. So could we find the circumference of the whole circle and multiply it by 1/4 to get this curve right here?
Oh wait,
Do you agree? Yeah, what?
since that's the fourth of a circle and we know that 250 feet, that looks like the radius for
This
one
is
side.
the radius. Good. So the radius is 250. We are finding the circumference or area right now. What are we finding right now?
The area. Oh, the circumference.
Circumference, so we need pi d. Well, if 250 is the radius, what is the diameter? 500 feet. Okay, so we're going to do 3.14 times 500. What does that give us?
1,570.
1,570. Now we said this was a quarter of a circle, so I'm going to multiply this times 1/4 or divide it by 4, either way you want to go. What do you get?
$392.5.
Whoa. Let me see what I got. 3.14 times 500 is 1570. Divided by 4. I got 392.5.
Yeah, that's what I
Yeah.
got too.
Whoa, okay, the answer key is gonna be wrong.
Well, the answer key.
Yeah, because I put 892.5.
What in last grade?
What the heck did I do to get 892? All right, and they want us to round it to the nearest whole number, so the nearest whole number is 390. Yep, 93. Unit is going to be feet. Oh, no, that's only this. What did we forget? We're putting a fence on this and this. So what do I got to add to it? That's where I went wrong.
250.
500?
500, because there's a fence here and a fence here. So 393 plus 500, 893. I did do it right. There is hope for me.
Wait. So there, that is.
893 is the correct answer.
So that's the fence?
That's the fence
Okay.
Of the whole entire.
of the whole entire field. We forgot to add the 2 straight edges. Yes, ma'am.
So for feet, for this, do we put feet in?
Did I leave feet out or did I put
No,
feet
you
in?
leave feet out.
Okay, then put in feet. Okay, are we good? Man, Miss Laird almost messed that problem up. All right, now they want to know about how big is the outfield. Area or circumference? Area. Okay, area is pi r squared. We already determined that this was 1/4 of a circle. So I'm going to do 1/4 times pi. We're going to use 3.14. What did we say the radius was? 250, and we're going to square that. Huge number. All right, so what do we get? Times 3.14 times 250 squared.
I got 6,000.
Yeah, that's what I get. 4 9
Okay, that's what we got. Now, they just want to know the outfield. So what do we have to do with this? Find the area of that and do what with it? Subtract it, okay? This has a diameter of 110 feet.
Yes, which is.
So what's the radius?
55.
Okay, so we are going to find the area of a circle with a radius of 55 feet. So take out your calculators, 3.14 times 55 squared, 9498.5. Okay, that's the infield. So this is the infield. This is the outfield. No, this is the whole field.
Yeah.
So what are you going to do to find the outfield? Subtract them. So we're going to take 49,062.5 and subtract 9,498.5.
And you get
39,564. And that is going to be feet squared. And what do they want to round it to the nearest hundred? So that there's the hundreds place. So what's it going to round to? 39,600 feet squared. And And you can put in the word square feet, or you can put feet squared.
For the first one to the near the fence, it doesn't say feet, but, oh yeah, it does.
Does it? Okay, I don't remember if I put the unit in or not.
It just wasn't right next to it.
Okay, are we good with that?
Yeah.
Yes.
That was a lot of work, but did you understand the process?
Yes,
Okay. Man, that looks like a mess.
it really does.
It's really not though. Here's all our circumference work, and then there's all our area work.
There's a lot of area.
Well, a softball field is pretty big. And we're only talking square feet, so that's how many tiles. I mean, the floor of tile right here is 1 square foot. Okay? That's a lot of tiles. We need 39,600 tiles to cover the softball field.
And there's only like about.
Okay. All right. Can I race? Can I race at home? Nobody's talking to me at home. Okay.
Yes.
I guess you're not there. Keep losing that. All right.
Well, I mean, it's a Friday.
While in math class, Pyra and Kieran come up with 2 ways of thinking about this proportional relationship. Both students agree that they can solve the equation 5k equals 1,750 to find the COP. Oh, I see where they got that. Do you see where they got it?
Yes.
Oh,
Okay. 5k, 5 times the constant is going to give me 1,750.
Oh.
Right? Doesn't that make sense? Y equals kx.
Yeah.
Okay? That's where that equation came from. It's just backwards. Do you want me to write it the right way?
I thought it was 5K, like 5,000.
1,750 equals 5k. And we're going this way. So k is what we're multiplying it by. Okay? All right. Kyra says I can solve the equation by dividing 1,750 by 5.
Yes, 350.
Okay? She says I'm going to take this and divide by 5. And she's going to get an answer. What did you say you got?
350.
350. Okay? That's what Priya says. Karen says, no way. I'm going to take this,
And divide by 1/5.
I'm going to multiply it
Oh,
by
what?
1/5.
I thought it said divide.
Just similar to.
Okay? He's multiplying that by 1/5. He's going to multiply this side by 1/5. Tell me what 1,750 times 1/5 is. 350.
Oh,
It's
so
it's
they're
more or
both
less
the-
just dividing.
What is 5 times 1/5? Isn't that 1k?
Yeah.
Oh, so tell me about dividing by 5 and multiplying by 1/5. Same thing, because dividing by a fraction is the same thing as multiplying by its reciprocal. Okay? So all they're doing is they're doing the same thing, but one is thinking in terms of division and the other one is thinking in terms of multiplying. And they're using the reciprocal.
I was.
Okay? Does that make sense? All right. And I believe, so how are they related? So what value did they get? They both got 350. So the COP is 350. How are the approaches related?
Those the rules.
They're reciprocals of each other. Very good. Explain how each student might approach solving the equation 2/3 k equals 50. How do you think they would solve that? What is Priya going to do?
Divide.
She's going to divide both sides by 2/3. What is Kieran going to do? Oh,
Here we can do that.
he's going to multiply both sides by the reciprocal. When you multiply by the reciprocal, that goes to 1k. Okay? Yeah,
So K equals what?
350.
Oh, okay.
All right, how do you feel about that?
Good.
Good.
You remember in reciprocal,
Yeah.
dividing by a fraction is the same thing as multiplying by the reciprocal. Dividing by any number is the same thing as multiplying by its reciprocal.
Any signs of life?
All right, that would be the end of today's lesson. That's the last lesson for Unit 3. Questions you have about circles? Okay, on Monday and Tuesday, we're going to take 2 days to do the review activity. Monday is a face-to-face day for the Monday people. Tuesday is a remote learning day for everybody. Okay, so we're going to start on the quests. I made them called quests on Monday, and then you'll have Tuesday to finish them, and then next Wednesday you'll take the test on circles.
Wait, so we have 2 days? We want Tuesday and Wednesday.
You have Tuesday and Wednesday next week are asynchronous days, remote learning days. Okay? Questions you have for me about circles? All right, if you're struggling, I've assigned you Khan Academy, which would be great practice. Okay, and there are videos to watch within Khan Academy and hints. All right, so have a great weekend. Enjoy your Halloween, and I'll see y'all on Monday.
Well, are you leaving?
You too. Bye.
Bye.